I'm Dr. Subhashri Mohapatra, and today we are going to see when to use ChiSquare test, T-test, and ANOVA test. So now, first coming to chi-square test. So what is this chi-square test? So chi-square test is a statistical test that is used to find out whether the difference between the observed values and expected values are statistically significant or not. So there are two circumstances under which you have to use chi-square test. So the first one is in case there are two categorical variables. So what is this categorical variable? Categorical variable is nothing but a qualitative variable. So what is qualitative variable? So there are two types of data, right? One is qualitative data, one is quantitative data. So as the name suggests, quantitative data is something that can be quantifiable. So you can attach a number to that data. For example, your DMFT index, or you're counting the decayed tooth in a person. So that is a quantifiable data. You can count how many decayed teeth are there in a person. Whereas qualitative data is something which you cannot count. It has no number attached to it. So one example of qualitative data is nominal data. So what is this nominal data? This is nothing but qualitative data. It has no number attached to it. For example, gender, race, color. So under gender, what comes? Males and females. Can you attach any number to that? You cannot attach any number to that. So that's why gender is a qualitative data. So in cases where there are two qualitative variables like gender or color, in that cases, in that case you will use chi-square test. So another circumstance where you have to use chi-square test is to analyze proportional difference. So what is this proportion? So I will give you one example. Suppose there are 100 children, and out of 100 children you find out that 40 children have dental caries. So what is the proportion of children who have dental caries? It is 40%, right? Out of 100, 40 children have caries. So proportion of dental caries is 40%. So in such cases where you have to assess the difference in the proportion, whether it is statistically significant or not, you use chi-square test. So I've given you two circumstances. One is when you have two categorical variable, or you can say two qualitative variables like gender or color, or if you have to compare the proportion between two groups. In that case you have to use chi-square test. Another important point which you need to remember is that it is a non-parametric test. So there are two types of test. One is parametric, one is non-parametric. So when do we use parametric test? We use parametric test when the population has a normal distribution curve, whereas non-parametric test is used when the population does not have a normal distribution curve. So here these are the important points you need to remember. One is that it is a non-parametric test. Second, it is used to assess the proportional difference between two groups, and the variables should be categorical. So now one example I will give you on categorical variables. So suppose your study title is knowledge of 12-year-old school going children towards smoking. So how will you know the knowledge of children towards smoking? You have to give them a questionnaire, right? You will give them a questionnaire. You will ask questions so that you come to know whether their knowledge is good or not. So suppose one of the questions in the questionnaire is, do you think smoking is harmful for your health? So the responses, once you get the responses, you have to tabulate them like this. So as I told you, chi-square test is used only for qualitative data, for example gender. So among these 12-year-old school going children, I want to know whether there is any difference in this smoking knowledge among males or females. Okay, male children or female children. In that case I have to use chi-square test. So how will you come to know? So in this question you would have given the options as yes or no. So here you can see there were 20 males and 20 females, right? 16 plus 4 and 18 plus 2. So out of these 20 male children, 16 of them said yes, that yes, smoking is harmful for your health. That means 16, the knowledge of 16 males is good, whereas 4 it is not good. And again 18 females said yes, that means knowledge of 18 females were good, whereas two females said that no, it doesn't affect your health. So in such cases you have to use chi-square test. When, so you can see here, this variable and this variable both are qualitative, you cannot quantify them, you cannot quantify males and females, you cannot quantify yes or no. So this is one example of categorical variable. Another example of proportions, I told you, right, in case of proportions you have to use chi-square test. So here is another example. So here you have 193 males and here you have 209 females. So out of this 193 males, I want to know the proportion of smokers. Out of these 193 males, how many males were past smokers? So proportion of past smokers, then proportion of current smokers. So this is another example where you have to use chi-square test, because here we have qualitative variables, males and females, you cannot quantify them. So this is another example of proportions, proportion of smokers among males, proportion of past smokers among females, current smokers among males and females. So this is another example of chi-square test. Next, coming to students t-test. So when do we use student t-test? Student t-test is used to assess the difference between the means between two groups. So here the key point here is two groups. For two groups we use students t-test. So again, student t-test are of two types. The first type is paired t-test. Okay, there is one type of t-test that is called paired t-test. It is also known as dependent t-test. In this, what you do is you assess the difference in the findings of the study between related groups. I will explain it you with the help of an example later on. Okay, paired t-test is a parametric test. This you need to know. Next, so what is the example? Example is any pre or post treatment in the same group. So in paired t-test, what you do, you have one group, only one group is there, and you assess the difference between the intervention and after the intervention. Okay, I will give you one example in the next slide. So the other type of t-test is unpaired t-test. So unpaired t-test is also called independent t-test. In this, there are two unrelated groups. So here you can see the difference between the two tests. This is dependent, this is independent. In unpaired, there are two unrelated groups, whereas in t-test, we have related groups. Then again, this is also a parametric test. So your example would be two different treatments given in two different groups. So here you can see in paired test there is one group, same group, whereas in unpaired test there are two groups. So in two different groups you give two different treatments and then assess the outcome. So I will explain it to you all with one example. So first one would be paired t-test. So in this what you do is, example is, suppose you take a group of 30 study participants. Next, you assess the plaque index at the beginning of the study. Okay. Then what you do is you give the intervention, that is a mouthwash, and you ask the study participants to use them for 3 months. After 3 months, you again assess the plaque index. So here I've written assess the plaque index post intervention. And then you compare the two plaque scores. So in such case, you have to use paired t-test. So here you can see you have only one group. In one group, and here is the intervention. So before the intervention, you assess the plaque index. After the intervention, you assess the plaque index and then compare the two scores. That is called paired t-test. Okay, in the same group, you are comparing before and after the intervention. Whereas what is unpaired t-test? In this, the example would be you have two different groups. Right? Earlier we saw there is just one group. Here you have two different groups. Again, you're giving two different intervention, mouthwash A and mouthwash B. So you have two different groups, two different interventions. So obviously you will have two different outcomes, right? So for group A, you assess the plaque score. For group B, you assess the plaque score. And then at the end, you compare the plaque scores. So here are the scenarios where you have to use paired and unpaired. That's why the name is there. Paired means in the same group before and after the intervention, whereas unpaired means they are unpaired, there are two different groups and you're giving two different mouthwashes for them, as in two different interventions. Next one is ANOVA test. So first thing you need to know what is ANOVA. It is analysis of variance. It is a parametric test. Next, here it is used for three or more groups. So what we saw, first one is chi-square, it is a non-parametric test. Next we saw t-test, it is used for two groups and it is a parametric test. Next is ANOVA, it is used for three or more groups. So here we have one categorical independent variable and one dependent variable. So categorical, I explained it to you all earlier. Categorical means a qualitative variable or a nominal variable, and the other one should be a dependent variable. I will explain it to you all in the next slide what is independent and dependent variable. Next factor is one way ANOVA and two way ANOVA. So there are two types of ANOVA. One is one way, in which you have one independent variable, whereas there is something called as two way ANOVA, in which you have two independent variables. So now I will explain it to you what is independent variable and dependent variable in the next slide. Yes. So independent variable is something that can be modified. That's why the term independent. It is not dependent on anything. It can be modified as and when we require it. Next one is dependent variable. It is a variable that is dependent on the independent variable, right? That's why the name is dependent. So I will explain it to you all with one example. Effect of diet on dental caries. So out of this diet and dental caries, which one do you think is a dependent variable and which one is an independent variable? So here diet is the independent variable, whereas dental caries is dependent variable. How? Because dental caries is dependent on the amount or type of diet you are taking. Right? That's why dental caries is a dependent variable, whereas diet is independent. Your diet is not dependent on anything. You can change your diet, right? You can modify here. That's why it can be modified. Your diet can be modified. You can increase your carbohydrate intake, you can decrease your carbohydrate intake. So diet is a modifiable variable or an independent variable. So these are the two types of variables, independent and dependent. Your dental caries is dependent on your diet, so it is called dependent variable. So here this is the example of ANOVA. So in case you want to find out if there is an association between low, medium and high levels of carbohydrate intake and occurrence of dental caries. So here which is the dependent variable? Dependent variable is your dental caries, and which is the independent variable? It is carbohydrate intake. So here you can see there are three groups: low, medium and high. So the moment you see there are three groups, immediately you have to know that you have to use ANOVA test. You have to compare between low level of high carbohydrate intake, medium level of carbohydrate intake and high level of carbohydrate intake, and you have to see whether the difference between these three groups is statistically significant or no. So here there is a table where it just shows the parametric tests and the non-parametric tests used in these situations. So I'll just explain it to you. So in case you have to assess the proportion, so difference in proportion between two groups, you have to use chi-square test, which is a non-parametric test. In case of two independent samples, you have to use unpaired test, which is a parametric test, and the non-parametric test for two independent samples is Mann-Whitney test. So again, next, two dependent samples, the parametric test is Paired Ttest and the non-parametric test is Wilcoxon sign rank test. Now next, for three samples, the parametric test used is ANOVA test and the non-parametric test is Kruskal-Wallis test. Next is correlation. Now what is correlation? Correlation, as the term suggests, you have to find out the relation between two variables. So suppose one variable, the magnitude is increasing, you have to find out whether the other variable is also increasing or reducing. So basically you're trying to find out the relation between the independent variable and the dependent variable. So for example, as I gave you the previous example, effect of diet on dental caries. So you have to find out that in case you are increasing your carbohydrate intake, is your dental caries increasing or reducing. That is called correlation. You're finding out the relation between the two variables. So for that, if you are using a parametric test, it is Pearson correlation test, and in case of non-parametric test, it is Spearman correlation test. I hope the class was helpful. Thank you.